Hi again, it's great to see you. This video shows you the secret to how to find the coordinates of the turning point. Did you know that when you complete the square, the coordinates of the turning point are literally there? If you want to know how to get to this point, the completed square form, you can watch videos on my channel on completing the square, all different types of quadratic equation and how to deal with them. My Instagram followers were having some trouble finding the turning point, and here we can have a look at some of the harder ones as well. That will be later in the video. But first, let's take a look at the simpler ones. So this first one is one of the more simple forms, and there are a few rules to remember. Later on in the video, we'll explain exactly why this works. But the trick itself is relatively straightforward. You want to find the x coordinate for this particular turning point. It's right in there with the x. Okay, so we look to this number. The number is 1. But whether it's a 1 or a negative 1, well, the rule is, and I'll prove it later as I said, but the rule is that we change the sign. Okay, so we're going to flip that sign. It's all to do with how we solve this for the roots. Where do we get our y coordinate? Right here, the number on the outside. And thankfully, nothing happens to that. You write it exactly how it is in terms of the sign. So we've got a positive 8 goes in as a positive 8. And this will be the coordinate of the turning point. I think the question is, what is a turning point? If we take this one, for example, we've got 1, 8. If we use our basic knowledge of how to deal with coordinates, we can put a little mark somewhere approximately equal to 1, 8. This would be the point which is maximized or minimized on our graph. The graph is a curve. It's either going to be a smile, just like this, or it's going to be a frown like this. And at the very top, or the bottom of the trough, so the bottom of the trough there, at the top of the hill up there, this is a maximum or a minimum. Obviously, if it's down there, it's going to be a minimum, and up there, a maximum. These are values of y, and as we go across this graph, we can see that we get to our highest height over there at the top, or our lowest low at the bottom. So if we can model a situation using a quadratic, then we can find the minimum or maximum points. Very useful. How can I tell if this is a positive or negative? Well, if I expand all of this, I can see that the x squared element of the equation will be positive. So I can tell that this is going to be smiling, something like this. And when you can see visually, I think it helps. So the turning point is where it stops going down like this, sort of reaches a gradient of 0, and starts going back up the other way. Okay, using what we know from the previous question, we can probably see this one quite quickly. The reason is coming later. And don't forget to put a negative 2 because we changed the sign. Here is where we get our y coordinate. And at this point you're thinking, it's a bit easy. Good. Remember, we leave the y exactly how it is. Okay, here we've got 3, but what do we do with that? We change it. Negative 3. Always remembering that we keep the magnitude, the size of the number. That's the important bit. And even if the y is negative, it goes in as negative because you don't change it. Okay, and this is the last of the relatively easy numbers. Excellent. So we've done all of the basic integers and we're pretty happy with it. Let's take a look at some of the more difficult ones that people were struggling with, and maybe strategies to overcome them or why they were struggling with them. I don't know what it is, but When decimals come to play, everything seems a little bit more complicated, but treat it just like we did with the integers. We have the negative 7.7. Now, because that's in there with the x, okay, that's the x coordinate part, and always does the opposite. That's a very good rule to remember when doing transformations of graphs. Anything to do with x transformations, think opposites. It will do you well. So instead of negative 7.7, we just have 7.7. And over here for the y coordinate, it's just a number, right? Just a decimal number. But we do keep the same sign. So keep the same sign. So it doesn't look very nice, but that's what it is. Difficult to plot, but hey. Again, do these Instagram posts because they're just a simple question every day. Keep you refreshed on the most important topics. And, you know, there might be a little bit of repetition here, but that's actually good. You start seeing micro variations and you see how things change and what changes make what differences. So, should I use that opportunity to say, follow my Instagram? Please do. Benefit. A little bit of practice every day. Coming into Halloween now. Really having fun with the Halloween designs. Not to be distracted, what we're doing here, we are 0.1. We change the sign. And here we have the y coordinate exactly as it is. Okay, now here is where the difficulties come. Many theories about what to do here, and based on, you know, bravery actually, taking a guess, why not? Thinking, okay, well, there's a 2, it's got to affect it somehow. Let's just do as we did before, because I'm going to tell you right now that it doesn't affect anything. There's 2 at the front, okay, it doesn't affect anything. So we're going to do it as it is, and then I'll explain very quickly why that's the case. So here's your root of this equation. If you were to solve this, just x minus 3 all squared, you'd get a 3. So our x coordinate is going to be in line with positive 3. And then if we take a look at the y coordinate, this represents a shift up of 18. So that's how it's transformed the graph. Okay, so those are the 2 things. So we started with whatever we did, x squared. The x minus 3 represents a shift to the right of 3. And then we look at the plus 18, it just goes up and down. But what is this? What is this here at the front, the 2? What transformation does that represent? Well, it's multiplying on the outside of this x bracket, which means it's affecting y coordinates. It's affecting the size of the y coordinates. So in effect, all of them get multiplied by 2. That has no bearing on the x position. And so absolutely fine to carry on as normal. Isn't that a relief? So with that in mind, here we have another question. Do we care about the 3? Oh, of course we care about the 3, but we don't need to let it affect our business. Minus 8. So the thing is, it's a prerequisite to care, I think. We don't care about anything. What do we have? So we have to care about that 3, but in this method, it makes no difference. We have our positive 8 as indifferent from the previous sign that we had, and then we have our y influence staying exactly the same. And I promised you some theories as into what people thought were happening here. And this 3, it might be obvious without the knowledge to do something like this. What did they do? Yep, they multiplied it by 3, right? 8 times 3, they thought it must have a multiplying effect. I do believe I also saw something like 8 minus 4. What happened there? Well, they thought that the 3 must have to scale down the negative 12 to make it in line with what had happened at the front. So there's a lot of things when you have no idea, the imagination runs wild, right? There's so many things that could happen. There's always something, some theory that we can think about logically that will help us. And in this case, graph transformations, to think about what the effect that's going to have on a coordinate. Because when you do the transformations, you have to do them in a certain order. So some of you are screaming, oh yeah, but what about then if that does transform the y coordinates, that should affect the 12. But actually, when we do the transformation, we do them in a certain order. So we start with our function, and this, in this case, the basic function is x squared. This will get transformed, and the first transformation happens immediately next to x, which is the -8 inside the bracket, which represents a shift to the right of 8. Okay, because it's right there next to it. That's the first transformation that happens to this function. Okay, that definitely does affect the x coordinate. The second is the 3 on the outside. It's on the outside, so it affects the y coordinate, and it has the effect of multiplying it by 3. And because the y coordinate currently is 0, then it has no effect. If we analyze what's happening now with the coordinates as we go along, x squared has its initial minimum point at 0, 0. And the 0, 0 gets then shifted along with the first transformation. It moves to the right 8. So now we are at 8, 0. And then when the 3 gets involved, it's multiplying the y coordinate by 3. And since that's already 0, it has absolutely no effect. So we still remain at 8, 0. So that's how you can see it has absolutely no effect. We can go on, which is where we are going to do the subtraction of 12. And the subtraction of 12 is going to then lead us to see the final shift down. And the translation down would mean our coordinate of our minimum point is now exactly where we thought it would be at 8, -12. Okay, so now we're really used to this. It's just going to clean up now. We have our -10 because we do the opposite when we're dealing with x. Might call x a shady character. -22 stays as it is, the shining honesty of the y coordinates. And there we have it. Very useful, right? And I think what went wrong with this question on Instagram was the size of the numbers, perhaps. But let's not get intimidated by numbers. We could have -2, fine. On the outside, that could be 7,000, 7 million. At the end of the day, the process tells us exactly what we're going to be doing. No real thinking needed, right? It's just the thing that is right there, it goes there. And that's what's so good about noticing patterns and using algorithms. You can take out a lot of the generalizations, take out a lot of the thinking, so we can think about higher order patterns instead. Now remember, all of the equations that you see in this video are already in completed the square form. So if you don't know how to get to that form first, please take a look at some of the videos that you see on the screen now that I've created on the rest of my channel. Hope you enjoyed the video, and see you in the next one.